Hi guys, so this is a quick demo of what I'm asking for you to do today. As you can see, this is very warmed up water. Our goal is to sort of see how water, temperature, and air interact within our own atmosphere to sort of understand what leads clouds to form, what leads precipitation to take place, how pressure plays a role in that, how temperature plays a role in that, and to slightly like model that for us. So in this jar, this water was just obviously heated up. It's bubbling. I'm going to open up in a second and you're going to see gases leave, and I want you to sort of be aware of that and take note of that as it happens. Right now, I just want you guys to think about, also when you guys do that, make sure you're wearing gloves or something, because steam carries more energy than liquid, and so steam burns are worse than water burns. And look at this burn that I got. See? Burn. Anyway, not important, or it is important for you to be careful with. But right here we have our hydrosphere, which is water. If I added some rocks or something to it, the landforms and water and air at least would have to move around it, and so that would be our lithosphere. We have our troposphere, we have our stratosphere, and our mesosphere would be somewhere up above this. So mesosphere is where it gets really cold all of a sudden. Hydrosphere is where it's water. Troposphere is mostly sea level. It's where you have gases. Most of our gases, it's where clouds are formed. Stratosphere is where there's an abrupt temperature increase. So if we look at this jar right now, the pressure, there's a lot of gases right above here, but the highest pressure and the highest temperature is here because heat rises. And so in that way, sort of this top area is our stratosphere. Mesosphere would be up here. And there are abrupt temperature decreases in your mesosphere. It absorbs a little bit of energy, but it emits a lot of energy. In just a moment, what I'm gonna do is open this jar up. And when I open it up, you guys are going to see we're going to see gases escape. I want us to pay attention to what happens to air as it cools, as the pressure rises. We're going to take a look at condensation, precipitation. That's how rain happens, right? So we're going to be taking a look at exactly what processes it is that leads to those things to happen. And then I'll turn on a fan so that we can see what happens to the surface of this water when we see sort of cold air meeting up with warm air. So just right off the bat, we know that warm air rises. So the hottest air is right up here. That means that below it is cooler air. And especially as I open this up, we'll see the warm air trying to escape, and we'll see a lot more cool air forming at the bottom. And then cool air will, as this warm air gets cooler, it'll start to move down, and that air starting to move down will lead to condensation. Alrighty, so right off the bat, you immediately see a lot of condensation up at the top. Remember, the top, the stratosphere, is literally where most of our clouds form, which makes sense because clouds are all condensation. I am going to go ahead and open this, so make sure when you open it, you're careful. Look for the condensation, look for how you see the water and the glass and things like that changing. Obviously, there's a lot of pressure buildup at the top because that's where most of the hot air has gone up there, right? So think about how the most of the gases are right here. The hottest air is up here at the top, as in a real system, right? That those gases can't escape, but here they're escaping. As they're escaping, what do we see happening on the surface of the water? Are you guys able to see that little bit, those gaseous types of condensation? Maybe a little. So that's what we see happening. That condensation is what we see forming as sort of the hot air cools. So for us, that might look like fog and also wind, right? We can see how when the hot air and the cool air meet, that gas doesn't necessarily last long. So that's essentially wind. All right, let's see what happens when I turn on a fan. Remember, a fan adds cold air to the system. So when I turn a fan on to the system that has a bunch of hot air, what might we see an increase of? Do you guys see the same increase in condensation that I see? Because as air cools, right, so this wind is taking the hot air that's evaporating and cooling it down really quickly. And as it cools, we see that condensation form. And again, that would be fog. Pretty much we're creating our own fog because that's a result of pressure. Also, like the fan is adding some cool air and it's sort of pressurizing that cool air and sending it straight down. So in various systems, a cold front, sort of forces condensation. So like on a sort of wet morning, right, we have our, on a wet morning, we see that condensation is forced, or the condensation that we see as fog or as dew is as a result of sort of that cold wind bringing stuff in. Also, when it's rain or snow, rain is like right at the beginning where you have all of that heat, you have that hot air, and then met by some cooler air or some less pressure or some lower pressure, and suddenly you have rain or snow or whatever it is. So really today what I want you guys to do is make some observations. What do we see happening as temperature changes? What do we see happening as the pressure changes? So right now, I would say that down here for sure is lower pressure. So what we want to think about is hot pressure, because heat rises, and with increased temperature is increased pressure. So the high pressure is here, the low pressure is here. As the air up here, as the vapor up here cools down, it'll move down. That's condensation. And then all of a sudden you have down here, you have low and high pressure meeting, and that is wind. Your warm air gets pushed up and that forms clouds. So sort of in this jar, we're modeling clouds forming because the warm air is suddenly being, when the warm air is pushed up to the top, like especially in the very, very beginning, right, where we had all that condensation up here, or all of those liquids, so that is condensation up here, those are like clouds forming. Then when we look and see how the cool air interacts with the hot air down here, we saw some like little bits of condensation sort of like coming across gently and then disappearing. That's like wind. Like as we watched that condensation come and disappear, that was wind essentially blowing it away. Now that we have the cool air from the fan coming down, we see condensation taking place. And in a lot of senses, that could be like fog. Like very quickly, that condensation existed here. And so that's fog. In another situation, it could have been rain. If my house was way colder, it could have been snow maybe. So really what I want you guys to do is just make some observations, be very careful, don't get burned. But there you go. We are manipulating weather from our homes in a jar. All right, let me know if you have any questions. Goodbye, friends.